Hi, my name is Fray Sarantes Galvan, and I'm going to be presenting you my investigation, structural and microstructural relation of friction stir welding aluminum alloys for space application. Aluminum 7075 is popular due to its high strength, which allows it to be used in the aerospace industry for building the frames of exploration vehicles called rovers. On the other hand, friction stir welding, known as FSW, unlike traditional fusion methods, performs a more uniform bonding of aluminum and is therefore studied as a very effective method capable of minimizing structural defects. The objective of this investigation was to evaluate the influence of FSW parameters on the microstructural properties and hardness profile variation of the aluminum 7075 T6 weld alloy. The methodology used was first to prepare samples and clean impurities. Then we perform the friction stir welding by varying the process parameters onto test specimens, perform the microstructural and microhardness analysis. For the results, we have that there were refined grains and fragmented intermetallics in the stir zone, along with a wormhole defect resulting from incomplete flow. The microhardness showed a V trend with the decrease in the nugget zone, as well as a few peaks from touching intermetallics along the measuring line of the union. The welding process resulted in the deformation of aluminum due to the heat and friction without reaching the fusion point. Instead, this process produces a fine grained structure. In the bottom of picture prop 2 can be observed a fragment of TMAC and HAC zones where the dispersion gets wider. The incomplete flow of material, however, produced a void which required the hardness measurement to be replicated above the zone targeted. The heat melted the particles responsible for the aluminum hardness, resulting in a decline in hardness in the areas near the welding point. Moreover, the tool broke up and dispersed hard particles, which caused the appearances of isolated spikes in hardness during measurement. For the conclusion, we have that the friction stir welding produced distinctive mixing patterns referred to as onion rings, without reaching to the fusion point but melting the material. However, parameters less than optimal affected material flow and caused the wormhole defect. In the meantime, thermal cycles cause the dissolution of hardening precipitates, resulting in the V shape of hardness prop measured in the nugget zone with respect to the base alloy. Mechanical fragmentation of intermetallic resulted in the formation of separate hardness peaks. The authors are grateful to Universidad Popular Autónoma del Estado de Puebla, to Università degli Studi di Padova, and Università degli Studi di Ferrara. Thank you.